Hello, my name is Chris Fernandez. Today I'm going to be showing you how to use the Network Emulator 2 to simulate a bad camera or a bad sensor on your car, on your zone architecture for your car, where you have multiple type of network going on. So you have 10Baset1s on the network or bus controlling your smart sensors, and you have a central computer. So I'm here. So I'm going to be using some parts from Intrepid and parts from our own solution. So to give you a better idea of what, in terms of physical topology, what we have configured here is I have a Novus card, and I'm using 3 ports on the Novus card, port number 8, 15, and 16. And you can think of the port 8 as being my central compute. So my central computer is going to be talking to the smart sensors that are based on 10Baset1s architecture here. So I have my central computer is given IP address of 100. I gave the 200 port here is the port that connects the regular Ethernet or automotive Ethernet network into my 10Baset1s. So my conversion here of the media between 10Baset1s and regular automotive Ethernet. My node 0 of my 10Baset1s or my beacon is going to be the Red Moon TOS1 here. So this here is considered to be node 0, and this is going to be offering the beacon for my 2 ESUs. In this case, I'm gonna simulate like a smart sensor. And part of the sensors, I gave them an IP address of .2 and .3 as node 2 and node 3. And they are actually my ports 15 and 16 on my network, or my AX network. So given this topology here, and one part that I left out here is actually what we're going to try to demonstrate here, which is the network impairment part, and that is done by the network emulator, which sits in line here between the port number 8, which is my central compute, and my media converter here. So this is the network emulator here. It goes from port number 5 to my port number 8 on my network test port. And my port number 6 here is connected to my media converter, the Red Moon T1S. All right, so given this IP address here, the schema is everybody is using 172.16.1/24 network. So we can talk IP with everybody here. I'm using IP just in terms of it's easier for it to understand. It doesn't have to be an IP, it could be a layer 2 network, but just for sake of um, demonstration here, I'm using IP just to make it easier. All right, so let's go to my topology. So what you see on the screen here is the IX network. Going back into my my topology. So this is the central compute, and I have 2 smart sensors here. They're connected to my 10Baset1s network. And I show them here as smart sensor node 1 and node 2. And they are just sending some health status or monitor now for my central compute. So that is about 5 frames per second. And let me clean here. And this here is my network emulator or my impairment tool, which is a web browser or a web-based a web-based interface with the 2 ports that I'm using, 5 and 6. And I think I have some profiles open here because I see I don't have a baseline yet. So all of my sensors are out. So I don't have any manipulation of traffic right now. So I'm going to stop traffic and start again, just so I have a baseline to see what we're doing. I'm going to stop traffic and start again. So in terms of traffic, I'm just using UDP traffic from both smart sensors here. I calculated about 5 hertz of traffic. So that's closely to 5 frames per second from each sensor. And they're both sending, as you can see here, they're sending the frame rate is 5 and I'm receiving 5 and everything looks good, right? So the first demo that I want to see is what we can do here first is to kind of make sure what we're sending. So I'm just gonna go into my port number 8, my test port, and actually collect some data to see what the traffic is coming in. So under data enable, I'm going to enable that and I'm going to start capturing. So this symbol here starts that I start the capture here. And after a few seconds, we can stop and take a look at the traffic. So I'm going to stop that. That collected about 86 packets. Let's take a quick look to see what we collected. So those are all UDP frames here, as you can see here, coming from 2 and 3. So 2 is my node 2 and 3 is my node 3. And they're going into my UDP port 3500, coming from the source of the DUP of the UDP port is 30,002 and 30,001, depending on the node 1 and node 2. So as you can see here, everything is coming in. The length of the packet is about 110 bytes on the wire, and with about 64 bytes of data inside, right? So everything is working. I'm gonna close this out. And the first demo I would like to show you is the ability for you to add some latency to the traffic. So let's just come back here into the scenario. So traffic is flowing from node 1 to end node 2 to my compute port here, right? So it's 5 frames per second here. As you can see here, the latency for each one of them is about, let's say, 70,000 nanoseconds here. So this is nanoseconds values. So now let's say I want to create a problem where my node 1, or this node 1 here, or my sensor 1 here, is kind of faulty, and I'm going to add latency to those packets they're coming in from that particular node. Remember that this node here is the traffic that I'm simulating traffic that's coming from the 10Baset1s, right? So in my network emulator here, it's very easy to do. I can already created here the 3 scenarios, so I don't do it on the fly and kind of make a mistake. So, but the first profile that we're going to look into is this right here, the high latency demo here. So I'm going to enable that one. So for that, I'm going to say enable this profile. By enabling this profile, when I have this, the way I create this profile, it's twofold. One is to create a filter rule, meaning how am I looking at this traffic that's coming in, and how do I actually make sure that that's the traffic that I want to impact. So for this high latency profile or demo here, I'm using the IP address of the sensor number 2, so which is this one here, and I can see it's from 2 to 100, which is my central compute, using IPv4 version. So when I enable this, I'm going to enable this profile. I'm not going to enable the impairment yet. So I'm just going to enable the profile. I'm just going to enable the filter rule, right? So that makes sure that this profile is being it's being used. As you can see here, I have 4 profiles. The default profile is the bucket on that catches all the traffic, right? So but my sensor here, 1, is supposed to be catching the profile or packets from that sensor 1 based on this rule here. And we can see if that is working by looking at the stats. So this stats here is for this particular profile. And the stats here, as you can see, I'm usually getting 5. So I know that this filter is being hit at 5%, at 5 frames per second, right? So which is exactly what we're seeing here. We're sending and transmitting at 5. The difference is that now the default profile is going to have 5, which is the bucket, which is the other sensor, right? So as you can see here, if I don't have this sensor on, and let's say here, I'll disable this sensor here. The default profile is going to now show 10 because it's going to catch both of them, right? So I'm going to go into the default profile just to show you this here. So now I have 10 here, right? So when I enable this profile, I catch half of the traffic that is I'm supposed to, right? So I'm going to go in here again. I'm going to enable this profile. So now that I enable the profile, I know that the traffic that I'm getting is the one that I want to impair. I can actually impair it. So part of this is now the filter rules is the what I'm trying to filter. Now the impairment. The impairment is I'm doing a delay. So I'm adding a constant delay of 1 millisecond into that traffic. So let's take a look here into where we see the latency now. So the latency now is about 72,000 nanoseconds. And when I hit submit, that's going to be changing. So I'm going to submit, and I now this average here should be going up. But since it's an average has been going up for a while, so what I can do is just clear the stats, and then we can see that this latency now should go to 1,000, which is exactly 1,000 uh, sorry, 1 millisecond here, which is what we added here. So that's what this should go, right? So this is, now we can see here that 1 millisecond or 1 million nanoseconds here. It's the new latency, right, for this particular frame, for this particular flow, sorry. But as you can see here, I'm still getting the same traffic. So I'm sending 5 frames and receiving 5 frames. The only difference now is that I increased the latency tremendously using this um, the sensor one here latency. Okay, so I'm gonna disable this and I'm gonna move on to the second one. So disable this and the traffic should go back to normal. So disable that. And now I can clear the stats again and we're back, we should be back on the baseline. All right, so clear the traffic. Should take a second and now we're back to the same latency. So for the second demo here, what I'm going to do is I'm going to drop 50% of the packets, right? So this profile here has the filter rule of now I'm picking up the IP address of the second sensor here, the sensor number 2. That's the IP address here. And the impairment itself is I'm dropping 50% of the packet. So my rate should go from 5 to 2.5. So let me go in here and I see the filter is enabled and I'm just going to enable this profile and I'm going to hit submit. As soon as I hit submit, that profile is now enabled on the port and the rate here should go down to 2.5. Yep, exactly what happened here. So I am dropping 50% of the packets coming from .3, which is my sensor 2. Okay, so that's clear enough. And as you can see, the latency here did not change. Nothing else changed um, on that sensor, right? So I'm gonna go in here and I'm gonna disable this profile, go back to normal. So going back to normal means my rate now is going back to 5. And as soon as that happened, we can go to demo number 3. So demo number 3, it requires a little bit of capturing the packet. So what I did here is a packet corruption. As you can see in the beginning, when we did the first capturing, we saw packets going from UDP source port to destination. So on the IP header, there is a protocol, a field for UDP header coming up, which is 17. So what I did here now, instead of capturing or instead of using the filter on the IP layer, I'm using the filter now on the MAC layer. So this here is the MAC address, the 012.001. Here's the MAC address of my sensor 1. So I'm capturing that traffic. And the impairment that I'm doing is I'm gonna change inside of the IP header. I'm gonna change the protocol from right now it's UDP to chaos, which is 16. So instead of 17, 16, and I'm gonna do that in one of the 2 packets. And there's 2 things I can do. I can do the correction, meaning that because now if I change the packet, the header sum was going to be corrupted and is going to be bad, right? So I'm going to leave it as is and do not correct. So the traffic is being sent right now. I'm going to submit or going to enable this. I'm going to enable this. And before I enable it, let me quick capture some traffic so we can see. So I'm gonna hit submit here, and now the packets should be corrupted. So now I'm gonna enable the traffic here, and I'm gonna capture for a few seconds. I see the traffic is still running. It's about 5 minutes or 10 minutes. So I just capture a few packets. Doesn't have to be many. 84 packets got captured. So I'm gonna take a look at that. I'm gonna open that up, and I'm gonna see the source here. So the source of the packet that I'm impairing only on node 2. So you can see this here, right? So as you can see here, the packet from node 2 is usually UDP from 301 through 350. And now every 2 packets, I'm adding this, I'm modifying the packet to have a different uh, protocol, right? So protocol for Ethernet, when I'm talking about headers, is going to be UDP, right? Protocol UDP here. So now I'm modifying to protocol to 16 chaos. And I did not do the correction, so you can see here now that those packets were being corrupted. The checksum, the IP checksum failed. I can correct the packet, or if I do correction here, then this packet will come in correctly without without seeing this. The checksum was going to be corrected. So let me, now that I did the correction here, let me capture again so we can see that. Capture again for a few seconds. I'm going to stop. And now let's take a look at this again. And this time, I'm going to see this chaos here, but you're going to see that, oops, you're going to see that you don't see the error anymore because the header checksum now is correct, even on the packets that I modified. So that's it. That's all I want to show for this demo. I know it was a little bit maybe too much information, and we went from we had too many things going on, but I hope gives you an idea of what we're trying to do here. We're trying to demonstrate, and how we can use the network emulator impairment for testing on a multi-network architecture. All right. Thanks for listening. I'll get back to you. If you have any questions, of course, feel free to reach out. I will be glad to help. Thank you. Bye.